Thank you for joining our session today. We call it Physics of Cloud Application Security. I'm Priyam Awasthy, work as an AppSec lead within Canon AMA. I live in Amstelveen. I'm an astrophysics geek who likes rock music. I have an experience of working with in the industry for almost a decade now. Previous to Canon, I was working with Deloitte as a cybersecurity manager. And I specialize in cloud security, focus on AWS, Azure, GCP, and DevOps ways of working. This session will be co-hosted with me with my colleague Spandan.
Hey, thank you, Priyam. Ex-colleague. So as some of you might know, my name is Spandan Chandra. I'm IT security specialist working for Ahold right now. Before this, I was also working for Deloitte around 7.5 years. I have a background in offensive security, and after that I moved to a little bit of enterprise risk management, wherein I moved to cloud security. So last 4 years is majorly focusing on AWS and Azure cloud, also DevOps, DevSecOps practices within the organizations. I myself, I'm living in Amsterdam for last 4 years now. I moved in 2018 to Netherlands, liking it so far. In my free time, I like to usually travel and play guitar sometimes. As well as I like to read a little bit of physics, as well as cars are my thing. So I think we can get started for the session then.
Thank you, Spandan. Moving forward, I see some news clippings, some interesting, infamous news clippings. Deloitte got hacked a couple of years back. Certain client secrets were stolen. Accenture got hacked a couple of years back, and also last year, again, sensitive information stolen. Tesla got hacked a couple of years back. Someone used their infrastructure for cryptojacking. Volkswagen got hacked last year. 3.3 million users' data stolen. Can any of you tell me what is common between all these breaches? All on the cloud. Nice. What else?
Cloud not properly configured.
Indeed. Yeah. Any other thoughts? They all could have been prevented. And that's why we are here. And the slide
below.
Thank you. Yep. So the agenda for today's session is going to be the physics of cloud application security. So we'll talk about different cloud migration strategies. We'll also talk about what different cloud-based architectures look like to get you going on the cloud. We'll talk about risk associated with these different cloud architectures. Then Spandan is going to be talking extensively about how to build security within applications hosted on cloud. And then we'll also talk about why a change in mindset in InfoSec very important from a cloud application perspective. Because Spandan and I both are geeks on physics, we have tried to introduce how general physics works with cybersecurity as well. Moving on. So the cloud strategies, I'm pretty sure most of you might have heard about them already. So these are the 6 R strategies that AWS noted a couple of years back. So just revisiting them, the hosting, essentially what we call with the applications lifting and shifting, pick up your on-prem systems, move them to cloud. Replatform is where the applications need some sort of replatforming, some changes in the platform. So you pick up those applications, tinker with the platform, host them on cloud. Repurchase is applications where it's better to buy an application by a cloud vendor or cloud marketplace rather than use your own application or move it to cloud. Refactor is an application where you might need to change something in the code and then move it on the cloud environment. Retain and retire are applications that you don't move to cloud. Retain is an application that you would rather have on your prem and secure it there rather than move it to cloud. Retire is an application, for example, Lotus Note applications from 2000 that should never be used anymore, but they are still being used. They should retire. Looking at different cloud architecture types, Monolithic is the most traditional cloud application architecture, which is still prevalent on cloud. This is where you hear the words infrastructure as a service and the applications which are hosted on virtual machines, still following, let's say, the 3-tier architecture, the application layer, the presentation layer, the database layer. So these are still quite prevalent on cloud environment and they're hosted on infrastructure. The next one is container-based microservices. These are the applications which follow or which are broken into sub-services. So essentially decoupled application sub-services which are hosted on cloud within the containers, Dockerized, have their own databases, have their own networks, have their own communication protocols, APIs mostly. And again, quite prevalent on cloud environments. And if we go further down the stack, we see the serverless framework coming in. This is where the sub-services of the application are even broken into functions now. So they're going to be functions for event-driven applications which are going to be hosted in cloud environments. They come in two flavors. There's a FAS and the BAS, function as a service. This is where you hear the words like Lambda, AWS Lambda, Azure Functions. BAS is backend as a service or mobile backend as a service when used with mobile applications. This is where you hear services like Firebase being consumed on cloud environments. Why knowing this is important and why deep diving into it is important was mentioned by Einstein a couple of years back. So he said if he had an hour to solve a problem, he would spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. And that's what we are here to do. We are here to talk about the problems and also solutions at the end. Talking about the monolithic security challenges. Obviously, I'm not going to be talking a lot about Awasthy Top 10. This is an Awasthy meetup. So I'm expecting everyone knows the Awasthy Top 10. Apart from what vulnerabilities exist within the application from a code perspective, from SDLC perspective, there are vulnerabilities that exist around the application on cloud. One of them, most notably, is DOS attacks or let's say security attacks against the APIs. Because when you move to cloud, most of the infrastructure is going to be talking via APIs, be it RESTful, SOAP, GraphQL. And these APIs need to be secure because most of the attacks are targeted against them. The next one is insecure access management. Not just how you onboard and manage your users, but also how the cloud services are onboarded, how the cloud services are managed, how, for example, network ACLs are created, how network security groups are created and managed. The other one looks very generic, the cloud misconfigurations, but it's a very key challenge because of which we see quite some attacks on the cloud-based applications as of now. Tesla hack was because of a misconfiguration. The hack that happened at Deloitte was because of a misconfiguration. So those misconfigurations should not be allowed in cloud. How to secure them? Exploiting the weaknesses within the virtual machines. Because monolithic applications are going to be hosted on infrastructure as a service, so you need to ensure that the virtual machines are properly secured. And this is where proper patching, encrypting the root volumes, and securing everything around the virtual machines becomes quite important. Talking about the protection of privilege trees. So we've seen organizations to achieve compliance, they encrypt all the sensitive data, and then they do not protect the encryption key itself. So this is where talking about protecting the keys to your kingdom is very important, and using third-party services or your in-house services for doing that. Spandan is going to talk about that later as well. Lack of visibility has been a cause of concern on cloud anyway because of the configuration drift. It's very easy that your application value chain grows 10-folds, 20-folds within years' time, and you easily lose visibility into what's in your network, what's in your cloud application. And that is where it becomes a challenge as well. Moving forward to the container-based security challenges. Like I spoke, once you create containers on cloud, they're going to be a decoupled sub-services of the application itself. They'll be, let's say, a payment module is separate from a user onboarding module. But these different modules, they have their own databases, they have their own networking ports, they have their own SSL certificates, they're also managing their own keys somewhere. That essentially increases the attack surface for an attacker as well. Now he has multiple ways to get inside the network of the application. In secure deployment settings, this is where we talk about if you're hosting container-based applications, do you allow sudo on the Linux kernels? Do you have root privileges allowed? Do you have insecure configurations like privilege escalation true? Those sort of, let's say, deployment settings. To talk about the runtime settings, how often are you ensuring that the registries or the images that you're deploying on cloud are properly secured? They are following, let's say, the ACR or CR best practices. Looking at the segmentation and isolation, like I mentioned, these databases or these containers are going to be talking to each other, but not all of them need to talk to each other. So are we ensuring that we manage that segmentation and isolation within the network? Are we following security best practices in deploying or defining different application hosting zones within the container itself? and not just inside the container. Credential leakage is something that we have seen extensively in the wild in the industry, where we have seen Docker images with encryption keys inside, developers packaging environment variables containing the keys, and it's still quite, let's say, extensively present in the wild. Insecure endpoints is always the main concern, where the endpoints are not encrypted, they're not using TLS certificates, and even if they're using TLS certificates just to be compliant, they're still supporting SHA-1 and MD5 algorithms together with that. So ensuring that you still ensure proper encryption for all the endpoints. Looking at the serverless security challenges. So like I spoke, the serverless framework is going to help you deploy applications and functions. And these functions are mostly event-driven. There are thousands of functions with different event sources, all using different encoded schemas, which is, let's say, a cherry on top for the attacker, because now he has so many input fields that he can play around with, tinker around with, and try to inject malicious queries into the input fields. We also talk about broken authentication, because if there are thousands of functions within the application value chain, then how are you going to manage the daunting task of assigning authentication to all these functions? There should be a centralized process. How are you going to create that? The next one is insecure deployment settings. So these cloud vendors like AWS, Azure, if you use the Lambda function, if you use the Azure functions, they give you very robust configurations, but it is not out of the box secure. It's not a secure configuration by default. You have to go and enable security into that. And unless we know how to securely configure those services, we're not going to be securing them. Misuse of permissions and roles, where we see developers assigning wildcard permissions to functions within the serverless value chains, leading to, let's say, improper access. There's also insufficient logging, which we also spoke about in the past, I think in the monolithic architecture, where the CSP has given you a very good facility to create proper logs, implement proper monitoring, but there is a human intervention to that. How are you going to implement that proper monitoring and logging? Like I mentioned, that we still see in the wild developers using encryption keys and secrets in the environment variables or in the configuration files of the software directory still out there. Denial of wallet attacks are quite prevalent in serverless. This is when an attacker doesn't want to bring your website down. They want to attack your finances. And because serverless applications or serverless framework is built in a way that you can be as scalable as you want, as fast as you want to. If 1,000 requests come in a second, they will allow for that. That will essentially incur quite a lot of bills for you. Insecure third-party dependencies is not just specific to serverless, specific to everything in the current age where we see supply chain attacks happening. But then again, in serverless, it becomes very difficult to identify those because you don't have control over the network or the behavior controls in the serverless aspect. What Newton thinks about it. So Newton mentioned quite some days back that every action has an equal and opposite reaction. And we think the more security controls you implement, the lesser the chances of a successful security attack. And we came up with the formula as well. If force equals to mass into acceleration, then security equals to control identification into effective implementation of those controls. We haven't verified the hypotheses yet. We're still in the process. Please don't test for that. So we've come up with 6 different domains of security where we should focus on when we talk about cloud applications. Access management, data security, securing the API itself, security configuration of the infrastructure around the cloud, the visibility and monitoring aspect, and operational security. And now Mr. Spandan is going to take a deep dive into these domains.
Thank you, Priyam. Let's have a quick look at the security controls that we just now see on the board. But before moving into that, I would like to present the concept of building the security within to the application rather than bolting it up later on, because it helps us to actually overcome a lot of cost issues when we have an application which is almost ready to the production stage and we try to do penetration testing on top of it and we identify issues. Then it takes a lot of time or backlog within the development community to actually fix those issues. Sometimes it's a patchwork. They don't even fix it at the root level. So if we have security built in within the application itself, it's much more secure. And as an attacker, it would be really challenging for me to actually hack an application by going into the code state of the code and like trying to hack it from that state. So talking about security, I think if we talk about security to even a layman, he or she would also say the first thing that comes to mind is access management. So we will also first of all see access management. One of the biggest issue in the companies, in the organization for access management is islands of security. What do I mean by that? Is that you have multiple opcos, you have multiple teams working with different solutions, and they have their own identity access management solution. And that creates a problem within the organization because you have multiple identities of the same person. The person needs to remember so many passwords, as well as if you want to decommission a person or decommission a system, or let's say a person is getting offboarded, there is a high chance that probably that person is not getting offboarded from all the systems within the company. And then it becomes another challenge from access management perspective. So the first thing to be avoided within the company would be avoiding these islands of security. The next one is choosing the protocol wisely. If you are, let's say, for example, an architect within the company, if you are a security person within the company, you have to really make sure that you are thinking ahead. You're not just thinking for right now, what is the best one available? Or let's say if there is a vendor, if they are offering me some solution, should I implement it? Thinking and planning ahead will save you a lot of cost as well as will make you secure in a long-term journey as well. So these are 5 of the most common protocols used for access management, I would say. Out of these 5, OAuth and SAML are the ones which are quite often used, at least from our perspective. We have seen they are quite often used when we are talking about applications within cloud. And then as a security person, we should be aware that what security protocols or how we should secure these protocols altogether. So for example, if we are talking about SAML, that we should know that it is based on backend, like if it is XML type of application which is doing backend in XML, it's more likely to use SAML. If it is OAuth 2, then we can understand that probably this would be using a lot of tokens in that area, so that we use OAuth 2. So these kind of things we need to make sure that we are covering. The next one is, this is not specifically a challenge which an organization has when they are developing the application themselves, but a lot of organizations are actually having SaaS applications within the environment. And we do not think it from access management perspective when we think about SaaS, but if you take a different view of the landscape, what you would see is if we are using SaaS applications, access management and most probably logging monitoring are the only things that we are responsible for as a customer of that SaaS application. And if we are not doing that properly, we are having a lot of challenges, such as, for example, we would have issues with shadow IT within the company. If we have a lot of processes for onboarding an application, offboarding an application, most likely the product owner, the project manager won't even go through those processes because it takes like 3 months, 6 months to onboard an application, go through the BSAs, go through all the assessments to actually onboard that application. Why you need that application right now, or probably you needed it yesterday. So that becomes a challenge, and then they would most likely bypass it, probably using their own credit card for the license and something like that. And you cannot secure something which you cannot see, right? So from an organization perspective, that SaaS tool doesn't even exist for you. But that SaaS tool most likely is also handling sensitive data of your company. So then it becomes a challenge. So we should also look from access management perspective for these kind of issues within the organization. Another issue which these kind of application cause is user password fatigue. What does that mean? That means that if I'm a user, probably if I'm a corporate user, I'm using at least 40 to 50 different applications for my day job, right? And if I'm using 10-15 password for each of the application, either I'll use a password which is probably my birthday or my wife's name or something like that, or maybe I'm using just the same password, which is very secure password, but the same password for all the applications that I'm using, which creates a challenge as well. So these are the major security issues that we have seen within the organization and should be dealt. They're very easy to deal with. So let's not make it complicated, and let's make it simple and try to address them within the organization. The second one that we have here is for data security. And in this one, I would like to mention something which is as trivial as you wouldn't use a sword for something where you can use a knife, right? Don't use a sword for cutting vegetables, right? So I've seen within the community, like especially within the security community, we have a tendency of implementing all the security controls for any type of environment that we see, right? But the challenge is it worth enough? What are we securing? What is the data that we are securing? Is it really critical to the organization, what happens if it gets exposed? If we don't ask ourselves those questions, it becomes a challenge, because everyone or every application does not have critical data, and every person is not working for banking organization with critical information or PII data. So it's not even worth it to actually go to the extent of encrypting everything and putting all the security controls on top of each and everything. So identifying what is required and then implementing those security controls is really important. And when we talk about data security, I think everybody would agree that the basic thing for data security is encryption, right? So when we talk about encryption, we have like majorly three types of encryption, let's say, from perspective of how we are encrypting the data. The first one would be encryption at rest. It's the most trivial one, or the most earliest one, I would say, encrypting the database or the rows or the columns of the database which has sensitive data. That is encryption at rest. The other one is encryption in transit, making sure that the APIs or the protocols that we are enabling those databases to connect with, they are secure as well. And the last one, which is probably the newest one, which we have seen so far, is if you have really critical database within your organization, you would also not want, when the data is being processed by a certain system, you would not want that to be exposed as well. In that case, you have data encryption in use, which is not something that we see on a day-to-day basis, but this is also one of the concepts that is being used for handling critical data in some of the companies. And the last one is giving keys to the kingdom. Priyam just mentioned about it. That means, like, if you have encryption, if you have access management, you implement all the security controls, but you lose your key, or you keep your keys just outside your door. It doesn't make any sense, right? But in security world, I've seen people doing that. As simple as keeping the hard-coded keys in the code, sometimes even exposing the code or the Git repository if it's misconfigured, exposed publicly. And in some cases, I was doing some of the assessments. I even found that, okay, the team is really aware about security. They're putting security walls and everything here and there. But the simple issue was where they are coding, like for development, they're coding in the Git. They're not using like Git secrets over there. And there they are hard coding password. So we have to think it in a pragmatic way. Within production environment, when we talk about key management, we have to ensure that we have proper vaults enabled over there for API connectivities, for applications talking to each other and all that. But if we are talking about development environment, we need to make sure that the development environment is secure as well. So that is about data security. Now moving on to the third security aspect, which is so API. API is becoming law of the land these days. I cannot even imagine an application which is not using API and is hosted on cloud, except for few monolithic applications maybe. To a certain extent, that some of the applications these days are nothing but APIs with a top level front end on top of it. So how do we make sure that the APIs are secure? Some of the commonly used APIs that we see, especially if we are talking about applications within cloud, are usually REST, SOAP, and GraphQL, Graph APIs. So as a security person, we should ensure that we know what are the, let's say, benefits and what are the downsides of using a particular API. For example, if we have an application within our organization where we are talking about high-level security, enterprise-level security, most likely we go for SOAP because it offers, so both of them, like REST and SOAP, they are SSL, they offer SSL, but SOAP will give you on top of it WS security. So probably you will go for that, but that might even create some type of latency. So in that case, you probably might go for REST because it will be much more faster than SOAP. As simple as if I take an example of, since I'm working in retail, if I'm working in retail, I want to create an e-commerce website and I have to query my data again and again. And I'm requesting, let's say, the picture of the product that I'm selling, the price of the product that I'm selling, but that's going to be a public information anyways, right? But that I don't need a latency over there. So in that case, probably I'll use the REST API. The third one is Graph API, GraphQL. This is recently being used quite a lot in the industry, specifically if you're talking about data analytics or tools that are offering data analytics. So Graph API is being used quite a lot, but this has brought into new security issues, I would say. Some of the issues which are related to GraphQL would be, let's say, the throttling, the depth of the query that you are putting. So if as a customer, I'm putting a query, or if I'm doing some UI based click on the website, But at the backend, if it is creating like 10 layers of depth within the graph QL that I'm creating, it becomes a challenge, because then I can easily understand that this query is taking more time. I'll put like a DOS kind of attack for that API. So then it becomes a challenge. So we need to make sure that we have appropriate security for that. And also throttling can be an option for such kind of API, for securing such kind of API. If you have a user which is putting like 10 requests per second, just block every user with like 10 requests maximum per second so that they cannot create at least DOS. If they are capable of creating DDoS, then it's a different question, but at least they cannot do DOS easily. When we talk about API security, since we are in OS Meet, I would like to also mention that OS has API security top 10 separately. Would be a good option to have a look at them as well. But when we talk about API security, what are the attacks that we are seeing in the wild? So some of the attacks that we are seeing for API are majorly credential stuffing, which is similar to, I would say, the brute force attack which we used to have in the web-based applications. Then there are stolen tokens, data extraction, and also account takeover. One of the important one here is the last one, which is partner breach. Most of the API ecosystem is based in a way that you are not just creating one application. You have multiple applications talking to each other, and sometimes you have third-party application, third-party APIs talking to your API. And if you are creating like a secure environment in your company, but there are 10 more vendors, 10 more third-party applications that your APIs are talking to, and they are not secure, if they are getting compromised, then we need to assess like what would be the impact to us. And this is sometimes in the organization something which is neglected. And it does not come into play until and unless one of our vendors or one of the third party gets hacked. So how do we secure APIs? There are few of the options, or let's say a few good practices to be followed when we are talking about API security. Some would be encrypting the data, making sure wherever we are talking about API, we are encrypting using the protocols which are encrypting the data with our API. The other one, as I just mentioned, rate limiting, throttling can be an option so that the users cannot automate and push a lot of requests to your API server. The other one would be using a service mesh. When you are talking about microservices, you have multiple containers talking to each other. Using a service mesh would be an easier option rather than creating your own setup with connectivities and encrypting each of the connections that you have in the microservice ecosystem. Okay, so we talked about applications coding, application creation. Now let's see how do we execute it. Once we create the application, then we are going to host it somewhere, right? Within cloud, we have an option of, let's say, so agile. Within cloud, we are so agile that we can just create an application, push the code into production. And to a certain extent that some of the application which we know today, having a lot of versions within a single day, a lot of releases within a single day. So how do we make sure that the configuration is remaining intact, or at least the configuration which was reviewed by the security team, approved by the security team, remains intact? So it becomes really important to have those security configuration in a secure way, and we can make use of industry available tools. So there are multiple tools like cloud workload protection management, which will see the workload configuration of your workload and make sure that it remains intact. There are options like cloud security posture management. It will go and check your network security, network rules, or probably your virtual machines, your Dockers are having the configuration which you intend them to, and they can be easily configured to actually either prevent a misconfiguration, or in some cases, if you don't want to go to the extent of preventing those, you can have like an alert raised whenever configuration is changed, which will raise an issue with the security team, and you can investigate that. Since we are talking about application security and we have talked quite a lot about SaaS also, so I would also like to bring Cloud Access Security Broker, CASB, which can be a tool used within the organization for SaaS management, shadow IT management, as well as making sure that your data is secure in a way that it's not getting passed through multiple SaaS applications. So one of the issue within the organization, which we have seen, is everybody is talking about vertical data transfer, where you're transferring data from your organization to, let's say, on-prem, from cloud to on-prem. And either you're talking about on-prem to cloud, but not a lot of people are talking about application to application transfer of data. If you have 100 SaaS vendors, 2 of the SaaS vendors, you say that they are handling your critical data, you get their SOC 2 report, you got all the assurance and everything, but maybe these applications are talking to some other applications as well. How do we see the security of the other vendors that we are talking to? So there CASB comes into play. where you can monitor the data which is going from one application to another application and make sure that you're not losing critical data over there. However, I understand since we are in OS, so some of the companies or some of the teams would not want to go with the costly solutions available in the market. But there are also, I would say, free open source solutions like OPA, Open Policy Agent, where you can configure these kind of rules yourself and implement it. You just need to make sure that you have the right set of talent within the organization to handle those. Okay, since we were on the topic of physics, and as mentioned, we are physics geek as well, I would like to bring another thought experiment, a famous thought experiment of Schrodinger's cat, where you have a cat in a box along with something that can kill that cat, like a poison box or something like that, and you close both of them in a single box. Until unless you open the box, you cannot understand if the cat is live or dead. So for you, it's both live or dead, right? In the same way, if we pick that analogy in the real world, your application, if you develop your application and put some security controls on top of that application and host it on internet, until and unless hacker goes there and hacks your application, to your application may be secure, may not be secure. So it's the same ideology, right? So, but there we were monitoring cat to make sure if she's live or dead. But here what you can do is you can also implement security monitoring on your application on the live, so that you can see that what is happening with the application and probably take actions accordingly. If I put it in simple terms, it's visualize, analyze, and monitor. So when I say visualize what are the use cases that could be possible, what are the things that can go wrong with your application. Then analyze is get all the logs in one place and try to analyze those use cases. And then monitor is either a SOC team or let's say created an automated alert. You can monitor those use cases so that if something goes wrong with the application, you are at least getting alerted if it is not blocked altogether automatically. So a simple expression for that would be the goal of the organization should be to catch exploits in moments and not in weeks. So we were also talking about changing the mindset. As we are seeing that a lot, as we are seeing that the technology is changing rapidly, as well as the development community is also changing rapidly. We saw that we were using waterfall, then we started using agile, then we went to the DevOps, DevSecOps maybe, and these days we are even moving to CloudOps, right? So as security community, it is really important for us to mature ourselves, because as the evolution theory goes, everything has to evolve or it perishes, right? So if we do not evolve ourselves, then we probably will become dinosaurs. So we need to make sure that we keep evolving ourselves as well. And I was just mentioning about DevOps. So what does CloudOps, or as I would like to call it, secure CloudOps means is we should enable the developers to to inculcate our security acumen in themselves, because some of the security controls that we were just talking about, let's say for example SAML, or let's say for example LDAP, or these kind of protocols, they should understand those protocols and they should also understand the security aspects of those protocols. Because as security community, we are not going to code it for them, right? Most likely not, in some cases maybe. But in that case, if they understand what does that protocol mean and how they can secure that protocol, it becomes easier for them to actually implement it. And as a security team, because in most of the companies, security team is always overworked. So it becomes easier for us as a security community as well, if they understand that and they already built it in the code, rather than us telling them each time to actually implement it. That being said, there are a couple of, I would say, friends that can help us. And these are the principles of security that we can assume within the organization to make sure we are moving to the right path. And those principles are, some of the people would even call them buzzwords, I would say. So the first one is zero trust. So zero trust is something that where you would say that each and every user and each and every application in your environment, each and every system in your environment is not trusted. Everybody has to be authorized, has to be authenticated. So if you create that kind of environment, I can understand it's not easy within an organization, especially already existing in organization, to change it in a day and say, now today we are working zero trust. But yeah, slowly and gradually, if we can move to that kind of ideology, it creates, it makes it more secure. The other one is security as code. We just talked about, if we can embed the security within the code itself, then it's not easy as an attacker to actually hack it as well. So that is something that we should aim for as an organization. And the last but not the least is defense in depth. That means implementing security on different layers. If I'm talking about OSI layers, also implementing it in different OSI layer so that it becomes like an onion. If somebody wants to hack you, it should become like peeling the onion, that they have to go through so many layers. Probably if they don't have enough motive behind it, they would even let it go in some of these stage. So that should be the ideology of the company. So I think this is what we wanted to share as a group. I hope you would have liked the ideology of connecting physics with security because this was our first go. We're trying to evolve the theories that we are coming up with, and probably if we meet sometime next time, we will have more theories connected with security.
But also a white paper.
Yeah, indeed. If you have any questions, queries for us, yeah, sure, please.
Hi, I am Moshe from Valo.
Hi, Moshe.
We mentioned about making sure that the developers know what they're doing. And you mentioned DAST. What about static analysis? Is it also part of the...
Yeah. So usually what we would prefer is, as a security community, static analysis is really good. Then you understand what are the issues within the code itself. If you implement DAST, then you also automate the part of pen testing it later on, right?
My experience, it's very important to embed the static as well.
Indeed.
Because when the developer develops, he's already or she in the context of developing and he's quickly to fix.
Indeed.
The further you go away from the development cycle,
I would agree to that. Yeah.
The other part that I was intrigued, you mentioned also the CWPP.
Yeah.
And it's talking about protection, and the focus of the discussion here is more about prevention.
Yes, indeed.
What part of protection is being done today, to your knowledge, of cloud workloads, like active protection? It's similar to the antiviruses on...
Indeed.
But what was active, because the threat model is a little bit different.
Indeed. So for active protection, I would say there are some CSPs which offer you those kind of solutions, like Microsoft offers you those kind of solutions, where you have Defender, which is getting analysis from so many endpoints that Microsoft has and embedded there in your workload. Another one, what I would say is, probably in the workload protection, you can also configure the workload protection in a way that you prevent certain actions from happening. As in, for example, if you create a rule that no machine in your organization should have port 22 open, as simple as that. So you already prevent that kind of thing from happening, right? So I would say that.
How customers are accepting this type of solutions? Because it's a lot of, I've heard a lot of customers that are against installing anything on their workloads.
Yeah, indeed. There are some cases where customers would not want to install that, and specifically if it is their critical data, they do not want it to be inspected by a third-party solution, right? In those cases, it becomes challenging. Sometimes I would say we have to go to a certain extent that we create kind of, not actually, but kind of air-gapped network for those workloads where you should not have this. But adoption of these kind of solutions, I'm seeing like last 3 years, it has increased quite a lot to a certain extent that companies like Palo Alto are aggressively working on in this area, and they are having these kind of solutions being embedded in many companies. So from the experience that I had so far in last 4 years for cloud security, I'm seeing they are being adopted more and more. Also, it gives you, let's say, for example, if you don't want this solution, you want your own coders, your own team to develop it, like the OPA solution that I talked about. But it's quite a hassle for the company, right? Because then you have to make sure it is getting updated every time. You have to maintain a team for it. Yeah. But these guys, these vendors are doing it day in and day out, right? They are getting the analysis from all the clients that they have, and you're getting benefit of that as well. Yeah.
Can I add something?
Sure, please.
It's not like a question. It's more for
Indeed, please.
What he talked. It's not just static code analysis. Now we can add plugins like IDA plugins, so the developer can have feedback immediately, and this plugin can be connected to your static code analysis too. So even better because it's immediately feedback. You don't need to wait for the building or anything.
Yeah.
And for protect the application in the other side, you can use like runtime application security. It's kind of new, or it's like have an EDR in your own application.
Yeah.
Makes sense. Yes, please.
Hi, my name is Joshua. I'm relatively new to this first time journey here. I noticed that most of the systems you discussed have vulnerability to denial service. So I was wondering, do you see the industry, what systems are they using to protect against denial service?
One of the most common I would say that they are using solutions like CloudFront. That gives you quite a lot of capacity to actually do that kind of activity that you are not getting impacted by a DOS attack. And if you are concerned about, let's say, if you are getting DOS attack, then you are paying the vendor, right? Because of the amount of traffic that you're getting. But some of these vendors also offer you, they detect the attack and they prevent those IPs and you are not getting charged for the attack. So they can see the normal path of, let's say, normal track of your application, and they can also see when the spike occurs. And based on that, you can have a discussion that this was kind of an attack and you were supposed to detect and block it. Even though you blocked it, you cannot charge me for it.